Okay, this is a review of the kind of inequality problems you might see on the Unit 4 test. So here's example number 1. There are several of these on your review. You need to solve this quadratic inequality. Now to solve it, you solve it like it's an equation. They are factorable, so go ahead and factor it. Set each factor equal to 0 and solve it. So we find our solutions at x equal 3 and x equal negative 12. Now you're going to take your two solutions and graph them on a number line. And then you're going to use your number line to identify 3 intervals of possible solutions. Now keep in mind that your solutions might lie in more than one interval, so you really need to test all 3. All right, so we're going to test a value in each interval. The first value we're going to test is negative 14. That's in the interval of less than negative 12. When we test negative 14, we find that it makes our inequality true. So we put a check mark there or mark it true, whatever you want to do. That will be part of our solution. Now we're going to check the interval between negative 12 and 3. When we substitute in 0, and I always pick easy math numbers when I can, like 1, 0, because they're easy to calculate, we get an answer of negative 36 is greater than 0. Well, that's definitely not true, so we're going to mark that interval false. We check the last interval with some value greater than 3. I picked 4, and when I calculate that, I get 16 is greater than 0. Well, that's certainly true. So I have 2 intervals where the values check out and 1 where it does not. That leads me to the answer for my inequality. In interval notation, I know that the interval between negative infinity and negative 12, or the interval between 3 and positive infinity, both make my inequality true. They are part of my solution set. If I write it using inequalities, then I would represent it as any x value less than negative 12, or any x value greater than 3. Let's go to our next example. Okay, now here you're given a graph and you are asked to write the system of inequalities that represents the graph. Now you're going to use some things that you learned in Algebra 1 here. First, you're going to identify the equation for the straight line, the linear line, by identifying the y-intercept and using what you know about rise over run to find the slope. The slope is 3 over 4 then, but you'll notice that that slope is negative. And then you are going to note that the y-intercept is 1. So your equation is y is equal to negative 3 over 4x plus 1. Next, you're going to write the equation for your quadratic inequality. Now, you can either find 3 points, 3 pretty points, and plug them into your calculator and do quadratic regression, which is what I did, or if you don't remember how to do that, you can recall the vertex form of a quadratic equation, plug the vertex in, and then use another pretty point to solve for A. Either way, your quadratic inequality is going to be y is greater than x squared plus 4x plus 1. That leads to the system of equalities that is the answer to this problem. Our last example. You need to prove that this system of inequalities correctly represents the graph. Okay, now how do you go about doing that? Well, you need to take each of these inequalities and put them in y equal form. In other words, you need y equal mx plus b form for the linear and a standard form quadratic for the quadratic. So I'm starting with the linear. I am going to subtract 11 over 3x from both sides. And then I'm going to divide both sides by negative y. Now stop here and note that when I divided both sides by negative 1, I flipped the inequality. That is very important. Please make a note of that. I hope you remember that from previous years of math. Again, when I divide everything in the equation by negative 1, I flip the inequality. And now I have a slope-intercept form equation that matches my linear graph. Next, I'm going to solve my quadratic for y. In this case, I'm just going to add x squared to both sides, and I am done. So, here is the system of inequalities. I can easily match both of those up to what's graphed, and so I'm done. Now, that proves that this system really does match this graph. Now that's the end of this quick review. Before I go, my daughter is here and she wants to be on this video, so she's going to say, "Hi, Mom." Now,
hi, Mom.
Say it again, Carrie.
Hi, Mom.
And all right, now this is the end of this review. Peace out. If you have questions, you need to go see one of the other Algebra 2 teachers. And if you have questions on this review, go back and write the problem down. Peace out, people. Good luck on the test.